Oh, and Deb from Mimbris. I also missed you, Deb. All right. So we got Deb down from Mimbris. Perfect. Okay. All right. Well, let's get started here. A lot to cover in this section today. I hope the reading is going okay on your end, and I'll try to summarize most of those important parts today, but then also go through some practice questions and hopefully add some context to this section. So just to review our schedule here again, so today we're doing health data analytics. We'll do the performance and process improvement chapter next month, and then we'll end with patient safety in June. And then in July will be again that workshop here at the association. So I think we'll be sending out info regarding that. We're just finalizing the agenda and everything for July. For the workshop, so you'll be getting that from us shortly. And I think we'll still need you to fill out the scholarship form. Everybody in here is pre-approved for all of the travel and everything, but we'll still need you to fill out the scholarship form as if you're applying, just for the intended purposes of the rules we have to follow for our grant. So look forward for that to come from Lydia pretty soon. We're working with Kim Workmeister, one of our consultants from California, on the agenda. She did the CPHQ workshop last year. It was very well received, and we're making some tweaks to it for this year. In particular, a lot of tweaks to this section, health data analytics. So this is the traditionally the most challenging of the domains for the CPHQ, particularly if you're not somebody who works in quality every day. There may be some lingo and some of the content that you're not as familiar with. I can tell you from last year's cohort, everybody passed the exam, but this was the one that folks scored the worst on. So it's just there's a lot to cover in this, and hopefully today we can be of help for that. So looking at what we're going to cover, we'll start with some discussion around confidentiality and the processes and procedures around that. And then we'll get into data collection. We'll talk about the various data types, talk about sampling procedures. So how do you collect your data, and what are the different methods to do that? We'll then get into the measurement and analysis piece, which will be probably the bulk of how we spend our time, and really the bulk of the on-site training and workshop. So going through really the different types of tools in statistics, and where to and how to use those tools becomes very important. So getting the lingo down of what those charts look like, what they stand for, how to apply them, when is it more appropriate to use one versus the other, all that sort of thing. Just takes some practice of going through examples and becoming familiar with that. So we'll do some of that today, and then we'll do even more of that in July. And that was really a request from the group last year, to spend more time on this stuff. So before we get into the data and the analytics part, there is included in this section is confidentiality and some of the rules and regulations and processes behind confidentiality. So just a few slides that we'll go over on this, and what NAECU goes over in their book, as you saw. Of course, there's mentioning of HIPAA and what that is, and the place that it has in the world of quality. So of course, the rules and regulations are driven by HIPAA, but they're also driven by a lot of state laws. And so that really makes it difficult for NAECU to probably test you on specifics, because some things vary depending upon the state. And yes, HIPAA is a national or federal thing, but state laws can sometimes drive procedures. So it's not, for the sake of this test, it's not important that you maybe have a deep understanding of all the procedures. But of course, in your everyday work, it's important. But so what NAECU reviews is they have these key components that you'll see here. Each organization determines policies around confidentiality and security, and they summarize really what has to be included in the policies that hospitals have. So just listing those out for you there, really it starts with the need to know guiding principle of protecting health information and who is accessing the information and why they are accessing it. So that's usually the common theme in all of the policies. And I know you've probably seen stories on the news of celebrities getting admitted into hospitals and then other nurses peeking in the medical record because they were interested about why that celebrity was in the hospital. And then, of course, there was sanctions and stuff after that happened. But that's kind of the context of what we're thinking of, is who is getting into the medical record and do they have a reason for looking at what they're looking at. Logging access. So all policies, or hospitals have to have policies about how they log access. So who has access to Epic? What in Epic do they have access to? When did they get that access? When did you take away that access? When they left? All of that has to be logged, and you're most likely those procedures are in place at your facilities. Releasing of HIPAA information. We'll talk a little bit more about that in the next slide. Processes and procedures for RCA reporting and securing the data, and then sanctions for those who breach confidentiality. So the how piece, or really the specifics of the policies, can vary a lot based off of the facility, but really they all have to have those core themes to them. So that's really all you need to know in the concept of what's important for this exam. It's also good to think about who owns the medical record, and that can vary a little bit by state. In New Mexico, the hospital owns the physical medical record, and then of course the HIPAA laws allow for us to share that with the patient or give copies to the patients and others. So not necessarily important for the test, but maybe important in your internal processes of thinking about ownership and how things are shared. That can sometimes drive some of your HIPAA policies. There is other states that have rules and regulations where they talk about the patient actually owns the medical record. But in most states, it's written as the provider technically owns the record. And then the HIPAA rules are the provider has processes and procedures to protect that information, and then of course to share that in various ways as appropriate. So again, I would, for the sake of this test, just kind of look at these pieces and those core themes. Outside of this, and probably further in depth than this exam, but maybe of interest for you all in your roles that you may not be aware of, is we have a legal manual, the NMHA legal manual, that goes into depth of a lot of the state regulations with stuff like this. So we pay a local law firm every couple of years. We pay them to kind of update that with all the rules and regulations and how that applies to hospitals and gives you guidance and all that sort of thing. So just reach out to me in email if you want a copy of that. We have the PDF versions of that legal manual. Again, it's specific to New Mexico and not to this exam, but since we're on the topic, I did want to mention that. So if you want a copy of that legal manual, please let me know and I can forward it in email. We're due for an update, but I think it's like 2 years old right now, but it's still really good information and pretty relevant. So just let me know. So the release of information and talking about HIPAA, again, this goes over some of the main policies and procedures around when we give information out and when we release that information. So these are just the key components of what has to be included. So obviously the patient's name and the reason for the release, the exact information of what, the exact, a little typo there, the exact information of what is being released should be that third bullet. So what that means is they can't just request the entire medical record. There usually has to be boxes that have to be checked of the specifics, like the H&P or the discharge summary or so on and so forth. Usually your hospitals are going to have that on your forms that folks have to fill out. So they can't just send a blanket statement of, "Well, give us everything." They have to kind of list out what they need. And then the period to which that release is valid. So on all these forms, when when we release information, when your medical records is dealing with that, those forms they usually have an expiration date on them, and they're not good forever. And of course, outlining who it goes to, and then the signature of the patient or the legal representative. So this is, again, good to have that basic understanding of those key components. But I think, you know, in New Mexico, we live in a very heavy litigation state, particularly towards hospitals. I drove from Los Lunas to our office here at the Journal Center this morning, and I counted. So I drive by most of the hospitals that you guys are at. I think I counted 8 or 9 billboards of attorneys off of the interstate. So I mean, this is the world we live in here in New Mexico. So I think this becomes pretty relevant probably in your day-to-day aspect of knowing these procedures. And it's not enough to think that who's asking for the information. So usually it's an attorney, of course, is asking for that information. They most likely don't know these rules, or of course they just refuse to follow them. So it's really our responsibility as quality leaders to make sure that these boxes are being checked when we're releasing the information. So it's pretty important to have that concept in you know, your day-to-day activities, especially if you're the one that is dealing directly with the outside attorneys. I can tell you from I was working at a hospital in Albuquerque a couple of years ago, and I got it was essentially a fake subpoena. So one of the attorneys in Albuquerque, they drew out this. They tried to make it look like it came from the county court system, that they were demanding a medical record, but it was actually something that he crafted. So you know, it's the Wild West for litigation in this state. So pretty important to have an understanding of this stuff in your day-to-day activities, but not probably something that gets tested too heavily for the CPHQ exam. So a lot to know on that. And again, there's good information in that legal manual from NMHA. If you ever want that, just let me know. Last slide on confidentiality. We have release of information without written authorization. So there is times where we don't need an additional form. So of course, patients come in and they sign that HIPAA form at admission that says who we're going to share it with, and so on and so forth. But within that form, it's going to have that language that says these are people that can have access to it without an additional form needed to be signed by the patient. So governing body of hospital, the CEOs, of course, the personnel involved with that care, quality leaders like yourself and the medical records department, they can access that information without an additional form to give them that access. All right, so let's get a little bit into, we'll shift to the data piece, and let's go through just one question to warm us up a little bit. So true or false, the polling question should show up. So just select data needs to be translated into information to make it useful for decision making. True or false? All right, good. All right, start off with an easy one. Warm us up a little bit. Good job. That's, of course, true. So it looks like 100% got that there. So little snip from the NACU here, just going over that data, transferring into informations and into decisions. A pretty basic concept, but something that they like to reiterate a lot. So an easy win probably for your exam. You'll get a question around that. Let's try another one here. Let me launch the next question. All right, so ICU director is measuring staff compliance with catheter maintenance, with the catheter maintenance bundle. So the pieces of the bundle like bag below the bladder, seal intact, all that sort of thing. Measuring compliance with the bundle and observing its effect on CAUTI rates. The measures above can be defined as the following. Both of them are process measures, both of them are outcome measures. The bundle compliance is an outcome measure, the CAUTI rate is a process measure, or bundle compliance is a process measure, CAUTI rates is an outcome measure. So looks good there. Most people got that one. Yeah, another basic concept that they like to test on to make sure that we all have the understanding of what process measures are versus what outcome measures are. So thinking about process measures as usually we're looking at steps in protocols or procedures and how they're followed, and then the outcome measure being, you know, the ultimate or the end result per se. So thinking about rates or things like that. All right. So put all the different types of sampling on one sheet for you guys. So looking at sampling, we're trying to look at what are the different ways that we get information from the population, or survey populations, or measure those populations. And the key here is having the understanding of the difference between probability sampling and non-probability sampling. So probability sampling having the stronger power per se and statistical significance, meaning we can take that sampling and generalize it to an entire population, so we can draw conclusions about the population. So simple random being like names of a hat, everybody's got the equal chance of being picked. Systematic sampling, so every nth case, every fifth case, every 10th case, or whatever it may be. And then stratified random, which is used pretty often, where we divide it into groups, and then each member of the group has an equal chance of being chosen. So, you know, maybe we're looking at readmission rates, and we separate it by groups of, you know, congestive heart failure, COPD, and maybe we put them in those kind of groups, and then we randomly select in those groups and then measure it that way. That would be an example of that. Non-probability sampling, so this cannot be generalized to the population, and a variety of things there. And as you read the descriptions, you can see why there is not as strong as a method as probability sampling. So snowball sampling, meaning patients suggest other subjects. So, you know, patients who had a total knee replacement are recruiting others, and you're going to survey them on something, or an expert survey where you maybe survey managers on staff satisfaction. Convenience sampling, which is used a lot, so that's really just using any available group that is used and doesn't have to be randomized. So maybe we're gonna measure satisfaction of New Mexico residents with New Mexico hospital care, and we just go to Central Avenue and we ask everybody on Central Avenue what their thoughts are. That would be an example of that. So, you know, obviously not much statistical power to that type of surveying. So all of these samplings, you know, it's good just to have a brief understanding of which one is. So if they describe it in a question, you can that pops in your head of what that stands for. But the practicality is you usually don't use only one. You can kind of use combinations of multiple ones. So data types, we'll talk a few slides about this. So pretty important to have that understanding of the different types of data. And as we get into the different tools, you'll see that the types of data come up again. So essentially there's two types of data and then kind of two subcategories of that. So categorical data being nominal and ordinal. We'll give some examples on the next slide of that. And then continuous data being interval and ratio. So I skipped too far forward here. So this gives kind of the definitions of each. So the categorical, nominal, and ordinal, what they are. And then so nominal being attributes, not necessarily values attached to those. And then ordinal being things put into categories and ranked. And then continuous being kind of more numbers driven. So sometimes it's always hard to remember the difference between which one has a true zero and which one does not have a true zero as far as interval and ratio. So a good thing to kind of study up on. And the types, when you look at examples, this will probably help provide some context really about what they are. So nominal being the categorical type. So thinking about this when we do like histograms and bar graphs and things like that. So we're going to look at, you know, separating groups into gender or race or surgical, non-surgical. And then categorical, the ordinal type is, so Likert scale is, so patient surveys, HCAHPS would be one where that's a categorical or ordinal type. And then continuous interval being values of a thermometer being an example. So again, an interval data does not have a true zero, so it can go below zero. And then ratio data being it has a true zero. So you can't be negative height or negative weight. It has a true zero to that type of data. So continuous data has greater statistical power, as you can imagine, than categorical data. So another little tidbit to remember about which type of data has more statistical power than the other. So analyzing data, we'll start very simple and then we'll get more complex. So memory lane back to middle school math class, mean, median, and mode. Knowing really what those are, how to calculate them. And so mean, of course, being the average, taking all the values, summing all those up, and then dividing it by the total number of values. And then median being the middle, so rank ordering those, and then taking the middle. If you have an even number like that example, then you take those two in the middle, and then you divide them by 2. And then mode being most often. So putting all those numbers out, and then the number that occurs most often, assigning that to be the mode. So you'll get a calculator for the test. And I think I got 2 or 3 questions on mean, median, and mode. So those were nice, easy wins for the data analytics category. But you'll get a calculator for this test, and of course their examples will have a lot more numbers. But they do like to make sure everybody has that basic understanding of those 3 things. So also thinking about analyzing data and reliability and validity and having an understanding of those differences. So reliability is the extent to which the experiment, test, or procedure gets the same result. So reliability, we usually are thinking also repeatability. How we measure the strength of reliability, there's the coefficient reliability. You don't have to know how to calculate that, but you just have to know that the closer that coefficient is to 1.0, the more reliable it is. And then also having an understanding of the different types of reliability. So inter-reliability and intra-reliability. So inter-reliability, thinking about between people. So maybe we're measuring the reliability of a medical device, and we have one nurse use that medical device, and then a second nurse comes in, and then a third nurse, and then we're measuring if we're getting the same result based off of multiple nurses or measuring between nurses. Intra-reliability, that would be that same nurse is using that medical device or over and over again. So we're kind of measuring the reliability of that same person, of them being able to get the same result. Or so you can also think about it in terms of like protocols, the reliability of protocols. So how those get followed between nurses, or how often those get followed with the same nurse. And again, repeatability being the key term with reliability. And then validity is the degree to which the instrument is measuring what we intend to measure. So, you have sepsis alerts in your EMRs and or EHRs, and is sepsis actually present when that alert happens? Is it measuring what it intends to measure? It's taking all this data in, and it's alerting you that says this is happening. Is that true? Or we think about HCAHPS. HCAHPS measuring patient experience. Is it actually measuring patient experience effectively or not? Is it measuring what it's intending to measure? So that being the term of validity. Okay. Now we're going to talk a little bit about variability. And I put these two together because sometimes they get confused with one another because they're kind of presented in a similar fashion. So these pictures kind of show that between when we're talking about standard deviation, and then we're talking about interquartile ranges. So the first difference off the start, and really the most important difference, is when we're talking about standard deviations, we're talking about means. So we're taking the mean of that population and then graphing it accordingly. So and we'll talk more about standard deviation as we get into some of the other tools, but this kind of goes over the percent of the populations that would represent falling within those standard deviations. So 68.3% of that is saying that within one standard deviation, that represents that amount of the population. And then the same is true with 2 standard deviations and 3 standard deviations. So you're taking the mean and measuring really the distance that particular person or that particular metric is from the mean. Interquartile ranges, that's data that's organized in using median, so it's not using mean. So it's taking that data and putting it from left to right and taking the median values and then looking at it in that fashion. So that's why this is, it looks semi-familiar to this one, but it's measuring something different, and it's taking averages in a different way. So interquartile, we'll talk a lot more about how standard deviations are applied and the ways that standard deviations are used. Interquartile ranges, one example would be clinical pathways. So I think we talked about clinical pathways on a previous webinar. So like clinical pathway for total knee replacement. So when a pathway is developed, how you develop a clinical pathway is you take the middle 50% of that population. You kind of take what does the average person look like? So for a total knee replacement, it would probably be what? It'd be a 60-year-old at a certain weight, or that sort of thing. They would kind of take characteristics of that population and of that median 50% of what they look like and their function, and then develop the pathway around that middle 50%. So think of it in that fashion of how you could use interquartile ranges. We'll talk a lot more about how standard deviations are used with data. All right. Let's see here. Another quick question. Nurse manager and pharmacists are trying to set priorities of contributing factors for medication errors that occur on the unit. The most useful data tool would be. All right, a little bit of spread there, but most people got it. A Pareto chart is going to be the most useful there, so we'll talk a little bit more about that. And when we talk about the chart and thinking about the test, you want to kind of memorize the key terms of what that chart or what that tool is doing. So you'll see on the next slide when we go over it, you'll see priorities of contributing factors, or setting priorities, and why Pareto charts are good for setting priorities. It'll have kind of these key words in it of what you're trying to do to help steer you towards the chart that you should use. So think about that in your studying, of having an understanding of how that it's going to be kind of displayed in that fashion. So like I said, so a Pareto chart used to help focus improvement efforts and prioritize contributing efforts. So it's data that's put into categories, and then you put it into a descending order. So you move all the higher categories to the left, and it's about that concept of the 80-20 rule. So 80% of the problems are due to 20% of the causes. That was the theory developed by this person. That is often followed. So it doesn't necessarily show cause and effect or knowledge about why it's occurring, but it just shows perhaps how or more where it's occurring. So This would be an example. So we're looking at types of errors that were discovered during surgical setup. So we have the frequency on the left. We have the different types of errors here. So we see wrong supplier, excess count, too few count as being the vital few, as they're called. So that would be the top 20%, or 80% of the problems coming from the, or 80% of the problems come from 20% of the causes. That would be kind of how you would prioritize. So if you're going to look at decreasing these errors, you're going to kind of start with perhaps analyzing this. So it's not going to tell you why it's happening, or a lot more information to find out, but it gives you kind of that first step of figuring out where to focus your efforts. So it looks a lot like a histogram, but it's just how the data is arranged in a particular pattern is different. So histograms are going to look a little more like this. So histograms will be evaluating a variable and then evaluating that variable on a different, whether it be across a time frame or a location. And then we're going to analyze the location, spread, or the pattern of that data. So an example here being distribution of patients readmitted to the hospital within 30 days. And it's looking at the days post-discharge when they were readmitted. So this is just looking at, a histogram evaluating that one variable of readmissions and looking at it across a time frame. You could do it. Another example would be if you looked at hospital readmissions and you wanted to look at, from which departments they're coming from. So the ICU and the med-surg and the neuro, or all that sort of thing, you could kind of, use it that way to help look at different patterns or spread and what's happening with the data there. So that being a histogram, this being a scatter diagram. So this is used to evaluate the relationship between two variables. So we'll spend 3 or 4 slides talking about correlations, and it's really to identify possible cause and effect relationships. It doesn't confirm cause and effect relationships, but we look at positive, negative, and no relationships. So we'll look at different examples of that and how that's measured, and what's strong evidence and what's weak evidence. But of course, the key theme with all this is knowing that correlation does not equal causation. So kind of a funny example here, we have rock music quality versus U.S. oil production. And you can see that they're following this same pattern. So if we didn't understand that correlation did not equal causation, we could say that as crude oil levels went up, the quality of rock music went up. So just kind of a silly example there. And it actually says the quality of rock music was best in 1967. I don't know, we could probably argue that. But so this kind of just shows that correlation, or lack of correlation, obviously, between two variables, and why we can't come to those conclusions so quickly. So positive correlation, so this is when the x-axis and the y-axis are moving in the same direction. So 30-day readmission rate, and then average hospitalization length of stay. So you'll see here what this is telling us is as the length of stay in the hospital increases, their readmission percentage also increases. So this is just a graph showing that possible relationship between the two. Negative correlation, so this is where they're moving in the opposite directions per se. So as the number of alcoholic drinks increase, the score on the dexterity test decreases. So you'll see this is moving, so they're moving in opposite directions. They're not improving or together, they're going in opposite directions. So as this gets larger, this gets smaller. That's what this is showing. So 10 drinks, our score is here, and it's a low score, where if we have a low amount of drinks, our score is up here. So this may be an example where correlation does equal causation. We could maybe see how that makes sense. And then no correlation, that is just where the data is scattered all over the place, And so you don't necessarily see a rise and a fall in a particular pattern. It's just kind of messy looking. So I know if we have some ER nurses or we have people who work at the ER, there's always that term of it must be a full moon tonight because everybody's showing up in the ER. Well, this highly scientific graph is showing that is not true. That the phases in the moon do not have any correlation with ER visits. Just a quick example of what no correlation looks like. All right, this will be the last polling question, and then we'll cruise to the end. Quality director is evaluating monthly fall rates spanning over the past 2 years. The quality director notes a few months of a spiked increase and is trying to confirm special cause variation. The most useful tool to assist would be a All right, we'll end the polling here. So most of you got it. Key term being there, like I said, there's always going to be those few words that kind of drive you towards a particular chart. So when we see special cause variation, as we'll get into the future slides here, we always want to think about control charts. So most of you got that, so good job. So let's talk a little bit more about those few things. Okay, so we'll spend a fair amount of time between these. The difference, and knowing the difference between run charts and control charts will be very important, and also probably very important at your organization when you're trying to drive change and knowing when to drive change or when maybe just to leave things alone. Both charts, of course, they have similarities. They look very close, as you can see there, and I know the font is pretty small, but I try to fit it in the slide there. So both are graphic displays of data over time. So we see, time here. Both serve the purpose of looking for trends. So of course, we're following these up and down marks and trying to make sense of what that means. Both are showing variations in performance, and both can help determine if change results in an improvement. So sometimes what you'll see on these charts, and you may do it with your own efforts, is sometimes people use these charts and then they'll put in little bubbles of we implemented a nurse-driven protocol here, or we implemented some type of EHR enhancement here, and then at this time we put this action in. So that can be a nice way to display the data and to show when you put in certain interventions, and then try to come to some conclusions about what has worked or what hasn't worked. So that can be really done in both of these charts, is using those little bubbles to input data about when you did different projects. But only control charts can distinguish special cause from common cause variation. So we'll get more into what that is and how that is, but they also are the only ones that can determine if a process is stable, and they do that by including upper and lower control limits. So upper control limit being here, we'll talk about more what that is, and then a lower control limit being here. So before we get into the control charts, let's do a little bit about run charts. So again, thinking about when we're reading run charts and trying to help ourselves determine if change has actually resulted in an improvement, we're going to look at perhaps some things like this. So understanding of what a shift in the data is. So that's when you have 6 or more points above or below the line. So this being a shift, this being a shift. And then a trend is 5 or more points moving in the same direction, whether it be up or down. So we got data moving in this direction, data moving in this direction, and that itself being called a shift. And then the last being number of runs. So that's a series of points in a row on either side of center. So The center being this line here, so we count this as a run, we count this as a run, and all that going forward there. Also, you can, instead of circling them like that, you can also count the number of times it crosses the center line. That also may be a way to do it a little quicker. So those being run charts, again, they don't necessarily tell us if there is much significance sometimes, or if we absolutely have to make a change. And then that's where control charts come in. They give us more specificity about whether the process is stable or whether it's just functioning the way it should be functioning. So that's what control charts are going to tell us. So yes, they're going to tell us where the variation is. They're going to tell us the type of variation that run charts cannot do. And then whether the process is stable. So those being the key terms of what you're trying to pull out of what a control chart is. So when we think of control charts, we think of statistical process control. So we have upper control limits and lower control limits. So going back to standard deviations, and we have some Six Sigma folk in here, so this is all review for you in the Six Sigma world, but we have, you know, the upper control limit being 3 standard deviations above and the lower being 3 standard deviations below the mean. So we're expecting that all of the data within those control limits are going to fall, or 99% of the data is going to fall in where that is. So what it's telling us is that if data is moving up and down within those limits, that's normal. It's inherent to all processes. It's never going to be perfectly straight lines and never going to sustain that way because of the complexity of what we do, but we do suspect up and down to happen. And that's where, you know, this comes in when you're making very important decisions about maybe organization-wide decisions. You're going to probably want to use something like this so that you really know, if you're going to put a lot of efforts towards something, you're going to really want to know that it's real variation that's outside of or not inherent to the process. So this is just telling us that the process is doing what it's supposed to be doing. And if you mess with this, if you mess with changes that are happening within common cause variation, you can actually make things worse. So there's a danger to that. So that's where these things come into play, is to help us understand that. Special cause variation is where it's outside of there. So then this is where we need to evaluate things. It's far outside those limits and showing us that there is some instability with that process, maybe due to environmental factors or process input factors, and we need to remove really what's happening there or fix what's happening there to get that process to be stable again. So looking for that, and let's see here. This one gives a little more examples of outside the control limits. So being here, being up here. We're going to want to look at, you know, fall rates in January to April, and if everything's above the upper control limit, we're going to want to find out what was happening between January and April, and make sure that we fix that, you know, and then we get some stability there, and then again at the same time maybe we see that again. So these are reasons to dig a little deeper and figure out what the heck is going on. Let's see here. Now we're going to get into, and I know we're close to the end. I'm trying to get us done in 45 minutes, so I'm going to take just a couple more minutes here, guys. So 2 more slides. Parametric versus non-parametric tests. So let's talk a little bit about that and having an understanding of the difference between parametric tests versus non-parametric tests and what categories of tests fall into those. So parametric tests, measuring data on a continuous scale, so going back to our types of data, interval and ratio data fall into parametric tests. So t-tests, we're looking at the difference in 2 means, so the difference in 2 populations per se. So 20 people in the NMHA CPHQ cohort complete training and take the exam. We take their scores and they're compared to 20 people who I wrote this wrong. It's not who didn't take the exam, who didn't take the prep course. So maybe we're measuring the effectiveness of these webinars, and maybe they stink and they don't work, and maybe the online review course doesn't work, or so on and so forth. We're trying to measure those effectiveness of people that did it and people that didn't do it. So kind of an intervention group and a non-intervention group. And then we take the scores, we average out those scores between the group, and we notice those differences between them. So that would be, how it's going to be portrayed of what a t-test is. So it'll be, you take one population, you give one of them the intervention, and then the other one doesn't get the intervention. And then you measure the results of that and see, did that intervention actually make a difference? And we know if it makes a difference based off of the p-value. So p being less than or equal to 0.5, that's going to give us some statistical significance, meaning that there is a difference between the group. So if p is greater than 0.5, it's telling us that that there's other factors, or it's purely just by chance of why one group did better than the other. So that's what we're always going to look for, thinking of statistical significance, and then of course thinking about, like I said, t-test, intervention group, non-intervention group. You'll see it kind of worded like that a lot. Regression analysis, so going back to the correlations, we talked about positive correlations, no correlations, negative correlations, and so we know what those look like, and just know that there's going to be an R value to that. So the stronger that R value is to 1 or -1, that stronger that correlation between those two are. So if it's a positive correlation, it's going to be put in a look like this, so 0.4. If it's a negative correlation, it's going to be -0.4. So just having an understanding of how that data is going to be displayed, the type of test, again, looking at relationships between variables and the strength of that relationship between the variables. And then the last parametric test that we all need to be aware of is a multiple regression analysis, so the effect of 2 independent variables on 1 dependent variable. So let's say we're evaluating the effect of discharge medication reconciliation and a scheduled PCP visit within 3 days on hospital readmissions. So we're trying to affect hospital readmissions. This number is dependent upon these things, would be that example. So we're trying to measure that effectiveness and that relationship of when we do this and this, does it result in this changing? And then the last test before we wrap up here, non-parametric tests. These are going to be used most common in healthcare, and just knowing that, going back to the type of data, categorical or count data, chi-square test is the type of test. Now, you don't have to know how to run a chi-square test. That takes software and things that are outside of this exam. But just having that relationship of knowing non-parametric test is chi-square test. And you probably saw this example. I just took this snip from the review course and looking at male versus female and keeping appointments for their doctor appointments. Same thing here, how it's measured, statistical significance. We're going to use that p-value to tell us if there is indeed a difference between the groups. All right, I'm 5 minutes over. I'm trying to hurry here, guys. I know you're busy. What's next? May 9th, we have performance and process improvement. So this is what we'll get into, of course, things like Lean and Six Sigma and PDSA and all these different kind of tools to use for process and performance improvement. So that will be a pretty heavy topic too, as far as the volume and importance of the topic, but probably more of a review for most of you as far as the content. So so before May 9th, if you could try to get through as much as you can in the textbook, and then also the online review course, that would help make these more productive. So I'm short on time, but I wanted to make sure, if you guys have any questions or comments, give you an opportunity for that. So whether you want to speak up or if you want to put it in the chat, we'll give you a few seconds. All right. Doesn't look like we got any questions, so that's okay. Again, we're going to go more in depth with this in July and do a lot more practice with the different types of tools. So you can brush up on it again before July when we have the workshop, but that will give you some understanding and some more application of it. Question here, what is the calculator going to be used for in the test? So yeah, you'll just get it. The calculator will be used to calculate mean, median, or the mean, or just the mean rather. That's all you need the calculator for, is to calculate the mean or the average. So I gave you the example of calculating the mean. It was like 5 numbers. You'll get some tests. You'll get a test question that's going to ask you to calculate the mean, and it's going to be a lot of numbers that you'll need a calculator for. So that was the only time I pulled the calculator out, was for that, to calculate the mean. Besides that, nothing further. Is there an audio review tape to purchase? There is not. In the review course, and Jackie, we need to get you, hopefully, I know you kind of switch spots with one of your coworkers. Hopefully you have the login information for the NAECU review course. There is videos embedded in the review course, particularly for this section, the data analytics. There is some videos that go, somebody must have been one of the lecturers for the content. There's videos of her talking through these tests, just like I did today. So that would probably be the only spot as far as particular for the CPHQ. Yeah, Jackie, let's connect afterwards and make sure that you're connected to the online review course, because I know you switched spots with Deanne, so we need to make sure you have her login information, because we only purchased for her. We can't purchase another one. You'd have to use her login, so we got to figure that out. Anything else? All right. Well, thanks for logging on, and I'll send out the recording and of course the copy of the slides. And if you have any questions between now and May, please let us know. If not, we will catch everybody next month. So you guys have a great rest of your week and a good weekend. We'll talk to you later.